Um, just a couple things to just draw from these two examples, I think, or at least things that I found interesting as I was researching and thinking hard about what it means. I think first, in these two cases, it can demonstrate that innovation is often a response to needs and to problems rather than that classic lone inventor coming up with the idea. That it's rarely an unprovoked idea, that at least for the Transistor team, they were looking into the deeper nature of their materials, and in the back of their mind they had, at least Shockley very much had that idea that if they found something it could be quite useful for the phone system, it could get rid of those proliferating switches and tubes. The solar cell, for instance, was a very clear response to a problem that Daryl Chapin had. I think the second thing we learn is that we're not very good at perceiving breakthroughs sometimes when they happen. The Transistor ended up on page 46 of the New York Times, and it was actually not even at the top of this kind of trivial column. It was located deep down at the bottom, saying, well, these Bell Labs guys might have a replacement for the vacuum tube. At Bell Labs, they thought it was quite a big deal, but it was hard for the rest of the country, and in fact the world, to perceive its immediate import, or at least most people. With the Bell Solar Battery, which is quite interesting, it was almost the exact opposite. It was a miracle. It was a pivotal juncture of mankind. It was on the front page of most newspapers in the country. We had harnessed the power of the sun, and I'm a big solar power advocate, so I'm not mocking it, but at the time it seemed like things had changed dramatically, that we had tapped now a cheap, inexhaustible source of power that would forever change our culture and our society. But to build on that too, I think there's a third thing, and that's that invention can be fairly rapid and sudden and dramatic, but innovation is really long and hard. And I think you see that with the Transistor, not just in how long it took to develop it to the point where it worked, but also it was quite expensive at the beginning. And in those early days, it was really kept alive by defense contractors. I mean, Bell Labs put them into the Bell system, but defense contractors in the US government were ordering them because the low power requirements of transistors and their tiny size made them quite invaluable in submarines and airplanes. And the extra expense, because they were much more expensive than vacuum tubes at the time, was outweighed by those other attributes. The silicon solar cell wasn't quite as hard to develop. However, it was incredibly expensive. I think in a year after they had developed this device, Daryl Chapin, one of the inventors, calculated that if he wanted to outfit his house with enough solar cells to actually power all his appliances, it would cost $1.5 million. It's obviously, we're at that point where the cost per cell is coming down dramatically, but obviously the economics made it completely a non-starter, essentially. And in fact, they pretty much realized this after they did that installation, that demonstration in Americus, Georgia, that for the expense of creating these solar devices at the time, it just wasn't worth it. Fourth, I think we see from these two examples, at least at Bell Labs, that there was no set way of making a breakthrough. The Transistor was an orchestrated, mid-sized team. It was very carefully created, and it was very closely managed in many respects. There was a good deal of freedom there, but it was always, everybody kept tabs on progress, and there were very frequent meetings. The solar cell, as I said, all those guys worked in different buildings. They found the right problem at the right time with the right people at the right moment. It was fairly serendipitous. Finally, I think that even when we think we understand the value of breakthroughs, maybe we don't. I think early on the Transistor was obviously viewed as a replacement for the vacuum tube, and it was. But its real value has been in computers, obviously, in the chips and that power our phones and laptops and God knows everything else. I think when I was looking in the archives at AT&T, there was only one letter, as far as I could find, from an MIT professor named Jay Forrester a couple days after the Transistor was invented. And he wrote to these guys and he said, hey, can I get a couple samples? I think those have some real applications in this computer apparatus that I'm building. And it's a little unclear from the responses at Bell Labs whether they realized that how valuable that would be for computers or not. What they did do was immediately write back to Forrester, and they were not writing back to everybody because they got tons of letters begging for samples, but they wrote back to them immediately and said, yes, they're on their way. Please let us know if there's anything we can do to make it easier for you.